progress.
See, those are online. Are you able to get? Yes or no? Did they speak? Those who are online are able to hear is what I asked. So yeah, last week I gave you a task, right? So last week I gave some work. What was it? Thermodynamics notes is what I asked you to complete, right? I went through the notes. Only few have completed. You have done, right? Why didn't you submit? Yeah. One video is left up. மொத்தமா இருக்கிறது 3 மணி நேரம். And I told you about the time allotment also. I gave it on last Thursday. And my throat is still bad. When can I get it? By tomorrow. By tomorrow, if it is not over, those who didn't complete will not be allowed to submit the books. Is that clear? Those who have completed, it is fine. I'm not sure those who are online, if I'm audible, listen to this carefully. Those who have not submitted your notes for thermodynamics, do not attend tomorrow's class. Even if you come in, you will be sent out. If it is online, you will be out of the room. Offline, they will take up. Is that clear? I want to see that work to be completed. And I think you had it for the exam also, right? At the time, you have put the answer. Right? You should have completed. No? So, are there any doubts? You uploaded to cyclic process. So, what is the state of the system? So, when you define the state, what are the parameters that define the state of the system? They are also called as state variables: pressure, volume, and temperature. So, if you are able to bring back the system to the same state variable condition, you call it as a cyclic process. So, when it is a cyclic process, you can follow any kind of process that you want. You can go in an isobaric process, then come in an isothermal process, then an adiabatic process, and then close it with the isochoric process, something like that. So cyclic basically means wherever you start, you have to come back to the same. It's like a round trip. Okay, but the round trip can be done in any way you want. It is not necessary that you need to follow only this process. And why did you write Carnot cycle? Carnot is in Asulia Tarli. Why did you write it? I saw your notes. That's not there actually. Pressure. That's called molar specific. CPC means. But you can do it at a constant pressure also. To keep it closed. See, in the bottle, you're supplying heat. You don't see, for example, I want to go to a constant volume. What I do is I'll apply pressure in such a way that the volume is constant. But heat, we should do some work to do it. It should happen at constant volume. Volume meaning the piston should not be pushed up. So if you're able to increase the temperature of a substance, of how much substance, of 1 mole of a substance by supplying how much? Q amount of heat, right? Then you to increase the temperature by either 1 degree Celsius or 1 Kelvin, you call that kind of heat being supplied as the molar specific heat at constant volume, depending on whether you are keeping the pressure constant or volume constant. If you want the pressure constant, you need to allow the system to expand in such a way that the volume is changing in proportion to the temperature. Other than the ideal gas equation or the PV is equal to nRT, you can play across different. If you are doing it across a closed system, So when you're doing across closed system, n is going to be constant, number of moles is going to be constant, r is going to be constant because it's universal gas constant. Appa PVT la I want temperature to change. Third parameter change agum. So pressure constant avukna or volume constant avukna. Pressure constant avukna, then volume is directly proportional to temperature. Volume constant avukna, pressure is directly proportional to temperature. And the very condition that you keep changing the parameters. That's called as CP or CV. Other end you have a relation, right? CP minus CV is called as R, which is called as Mayer's equation. Mayer's relation. Adhe mari CP divided by CV is called as gamma. You asked about the adiabatic process. You remember the derivation. That's where CP by CV what is gamma. Other we write it as PV power. And the derivation why PV power gamma is equal to constant. But there is a derivation for that one. Okay. So PV power gamma also you should have showed, right? Differentiate on both the sides and then proceed. Log of something in the steps. உனக்கு ln க்கு log க்கு வித்தியாசம் இருக்குதா? Explain it. The chemistry la kuda படிச்சிருப்பீங்க. Ln, see mathematically whenever you integrate dx by x, so whenever you integrate 1 by x, it is always log base e, correct, which is called as natural logarithm. அதே மாதிரி log to base 10 கூட இருக்கும். That is called as common logarithm. So the log books that you are using is actually common logarithm. It's not natural logarithm. So whenever you want to convert log of a base e to something base 10, then you need to multiply with a parameter called as 2.303. அது இருக்காதுல 2.303 RT divided by I would have explained that point. See, if at all you don't know the reason for it, it is very simple. There is a property of logarithm. Log a base b வந்து log a base c into log c base b ன்னு எழுதலாம். இருக்கா? அது எப்படி பண்ணனும் கூட காட்டியிருக்கேன் நான் சைடுல. So log a base b is log a base c into log c base. Okay. இப்போ இந்த இடத்துல e இருக்குன்னா okay, log of, for example, I have RT something with it. ஏதோ ஒரு equation எடுத்துக்க RT base e இருக்குன்னா I will write it as log of RT base 10 into log of 10 base e. So log of 10 base e would have value da, it is 2.303. Enough for that you need to understand the basic logarithm. About this, actually you should have had a 9th standard, but the logarithm you could have not learned it in depth. You would have not learned it. There are certain properties. Basically, you have to speak in terms of mathematics, right? Hey, those who are online, at least now speak. Am I audible? I can't shout much. Speak, don't. So, yeah, good. So, exponents. There is something called as exponents. A power x into a power y. You would have learned in your lower grades. 9th standard. A power x plus y. It is called as exponents. Whenever you talk about a function, you know what is the relation of a function? For a function, there is something called as an inverse operation. If I write sin x is equal to, sin x is equal to half. Sine of an angle is giving you half. Okay. Appa x vanda I will write it as sine inverse of half. You should not read it as reciprocal of sine of 1 by sine half kadayadhu. It is sine inverse of half. Inverse function is about which you learn next year in your mathematics. Okay. The basic of in the year you would have learned about functions. Like when I'm going to teach you the oscillations, that's most of math. And the time light up free only. So what exactly is the mathematical meaning of it is, if in English sine of some angle is giving me a half. What is the angle? That angle is basically written as sine inverse half. That is why you would have seen most of the times you report the answer like this. Sine inverse half is known to us, 5 by 6. But as one of the answers, it is not only 5 by 6. You can write 5 pi by 6 also. Yeah. Because in that cycle, sine can generate half at multiple places. In the first quadrant, it is 5 by 6. The second quadrant, it is 5 minus 5 by 6. அதே மாதிரி திருப்பி ஒரு சைக்கிள் முடிச்சுட்டு இருக்கும் 2 pi plus 5 by 6 ஒரு 13 pi by 6 அது மாதிரி போயிட்டே இருக்கும். So that's called a general solution. அதுக்கு தான் நம்ம எழுதுறோம் பத்தியா. So coming back to the same point, the general solution is needed for you to understand waves. அதனால தான் touching it. So இப்போ புரியுதா inverse என்னன்னு புரியுதா? To some extent you are able to understand right, what is inverse. இது இன்னும் டெப்தா போனா you have to understand what is composite function. I'm not getting into all those things. அதே மாதிரி exponent should inverse operation is called as logarithm. It's not reciprocal operation, it is called inverse operation. Meaning enna log of a, see for example, can someone tell me what is the value of log 1? What is the value of log 1? Any idea? Hello? Base enna venal put. You can put any base. Log 1 is a fixed value. It is always a 0. You know why? Because log 1 base, for example, I put it as a. The meaning of it is log 1 base a, if I write it as x, then 1 is equal to a power x, where a is a non-zero number. Non-zero and a non-negative number. Base of a log cannot be negative. And the functions are படிச்சீங்களா? Log x base a there is a range value for a. Domain define பண்ணுவாங்க. Next time observe, go open your math textbook and see what is the domain of the base. The insert here, it is there. And graph on the paper. Pathirkingla. Domain yapan. Log. Would have learned, no? Exponents log. Maybe I think 11th or 12th, I remember it is for sure there. Fine. If it is not there, it is fine. So 1 is equal to a power x. Just I'm telling you that the base cannot be 0 or base cannot be negative. This is the point. So a power x now, anything power x is giving you 1. So what should be the value of x? A cannot be 0. That's what I told. A cannot be 0. A should always be greater than 0. Base can never be 0 or non-negative. Another a is given as always greater than 0. புரியுதா? அதே மாதிரி log of a base b into log of, இப்போ இத மாதிரி ஒன்னு இருக்குன்னு வெச்சுக்கோங்க. So what would be the answer for this? What is log a plus log b? Log ac base b தெரியுமா இது? தெரியுமா தெரியாது? Okay, தெரியுதுன்னா my question, you know this right? You know this problem. Yes or no? Confident as well. தெரியும். Okay. My question is, how did you get it? With the basics I taught you now, can you think? It's very simple. Log of a base b x ன்னு எடுக்கிறேன். அப்ப a என்னது? b power x. அதே மாதிரி log of c base b y ன்னு எடுக்கிறேன். Then what is the value of c? b power y. புரியுதா நான் சொல்றது? இப்ப I have AC அப்படின்னா எவ்வளவு வருது? b power x plus சொல்லலாமா? So there is a property like this. இப்ப AC is equal to b power x plus y. Can I call this as an equation of exponents? ஏன்னா equal to symbol இருக்கு. I have exponents. So it's an equation of exponents. If I take log on both the sides, log of AC with the base b, then this will be log of b power x plus y base 1. Okay. எப்பவுமே இங்க இருக்கிறதுக்கு பவர் இருந்ததுன்னா it will become a multiplication factor. So that will be equal to x power x plus y into log of b base b. Log of anything base itself is 1. Okay? Because log of a base a is equal to, for example, z ன்னு எடுக்கிறேன்னு வெச்சுக்கோ. அப்ப a என்னது? a power z எவ்வளவு இருக்கணும்? So log of anything base anything is 1. So இது 1 ன்னு இருக்கும். So log of AC base b is x plus y, but x plus y என்னது actually? Log a plus log. So you do the same operations. So if you logarithm, if you want to prove anything, you have to convert it to an exponent and then solve it. That's logic. அதுக்காக தான் I showed the proof. It's not necessary you need to know it, only for your understanding issue. So, இதே லாஜிக்ல பார்க்கும்போது why I'm stressing on this point is most of them don't know why the 2.303 is coming and most of them don't know when to use it. இது வந்து the same thing is applicable in your chemical thermodynamics also and the same thing is applicable in your physics also. So அந்த 2.303 எப்ப யூஸ் பண்ணனும்னா when the log ஓட பேஸ் வந்து 10 ன்னு இருந்தா. இப்போ log ஓட பேஸ் வந்து e ன்னு இருந்தா you should not put the 2.303 because if this question comes in MCQ, if they put the option as 2.303 into log base e, that option is wrong. 2.303 into log base 10 ன்னு இருந்தா மட்டும் தான் the option is. Be very careful. They will confuse you. புரியுதா நான் சொல்றது? So that point, register it in whatever language you understand. உங்களுக்கு எப்படி புரியுமோ அப்படி எழுதுங்க. Right. Inverse of exponent. Logarithm is a function. It's an inverse of an exponential. Inverse na sonna inverse puriyadhu. You need to have in-depth knowledge of functions. That you will anyways understand only next year. Anything else? Any other questions? Yeah, if you understand and take down the notes, you put it for my sake. If you guys understand what you wrote, each and every word is clear. Except the doubts you are asking. Clear or not? See, E value is 2.7132. It's a fixed value. E value is 2.7132. It's a fixed number. E is a special number of exponents. So log E base, sorry, log 10 base E இருக்குன்னு வெச்சுக்கோங்க. இப்போ நான் என்ன பண்ணிருப்பேன்னா இங்க பாரு log r இது வந்து புரிஞ்சதா? இந்த ப்ராப்பர்ட்டி தான் யூஸ் பண்ணிருக்கேன். Log a base b, I wrote it as log a base c into log of c base b ன்னு எழுதிருக்கேன். So log of if rp base e இருக்குன்னா rp base 10 into log of 10 base e input means I split the base here. இதே தான் இது. b இருக்கிற இடத்துல e இருக்கு அவ்வளவுதான். Okay, and c இருக்கிற இடத்துல 10 இருக்கு. So log of 10 base e would have value than 2.303. Why? Because log of 10 base e வந்து நான் x ன்னு எடுத்துக்கிறேன். So 10 is equal to how much? E power x. E would have value of 2.7132 something to the power x. And the 0.71 மறந்துரு. 2 power x is equal to 10 na, what will be the minimum value of x? So 2 power 1 is 2. 2 square is 4. 2 cube is 8. So minimum value of 3. So 2 power x வந்து 10 இருந்தா x would have value 3 point something. But இது என்ன value? It is something closer to 3. So 2.7132, if you raise it to the power of 2.302, that will give you a value of 10. Another the value 2.303. Right? Any other question? Clear? No other questions? Shall I proceed? So no more questions from this chapter. Nothing. See, listen. As I mentioned, I'll be starting the 14th chapter, which is very, very, very important. Okay. So write down the heading as chapter 14, oscillations. Right. So till now, see again we are coming back to mechanics. In between, what happened? We deviated to the thermal physics part, right? So thermal physics, thermodynamics, kinetic theory of gases. All these are thermal physics. Now we are again back to mechanics, that is oscillations. In some books, this chapter is also referred to as simple harmonic motion. It's called as simple harmonic motion. The simplest in the acronym form, you write it as SH. Now the question is, till now we have learned about translational motion, rotatory motion, and all those things. Now we are going to concentrate on another type, which is vibratory. So vibratory is also called as an oscillatory motion. So we need to understand what exactly is it. But before we understand what is a vibratory motion, we need to understand an important term called as periodic motion. So if I put a question of what exactly is periodic motion, what will you say? In your own terms, what will you say? So name is suggesting something. Periodic motion. What is it? Sorry? So if there is any motion that repeats itself during regular intervals of time, you call it as a periodic motion. So basically, what is it? Motion that repeats itself during regular intervals of time is called as periodic motion. Now the question is, what are the examples of periodic motion? Can you tell me an example of periodic motion? Oscillatory is one such kind. Can you give me better examples of periodic? So rotation of Earth, revolution of the second and the minute hands of your clock. This fan revolving is a periodic motion. Provided they rotate with constant angular velocity. If not, they cannot. No, they cannot repeat themselves in regular. Rotating time period mark. So what does the definition say? In regular intervals of time, that is the most important word. Okay, so rotation of fan, then what else can we take? Can I take an oscillation of pendulum? Okay. C base term. That is a wave-like structure. That has different meaning. I'll talk about it later. That is a wave actually. Okay. Now, the next question is, I'm going to talk about, see, what I'll do is, I'll connect physics and math. I'll be doing it like that. The next question is about, what is the periodic function? What is the periodic function? So whenever the word function comes, it is mathematics. The word motion comes, it is physics. There is a prefix will be the same, right? So what is the periodic function? If I have a function f of x like this, right? if f of x plus capital T is equal to f of x, then this f of x is said to be a periodic function. This is a mathematical definition of it. So what did I say? If a function of x plus capital T is equal to f of x, then you call it as a periodic function. Best example is, okay, where this T is called as the period of the function. So if you look at an example, if I have f of x is equal to sin x, to that x, I need to add an argument. An argument is an angle. So I need to add an argument in such a way, I get back sin x. So what is the least value that you can add? When will sin x again come back to sin x? So f of x plus t is equal to sin x. So there are two options here. I can write sin of pi minus x is equal to sin x. Correct? Or I can write sin of 2 pi plus x also to be sin x. Which one is correct? I can write it in both the ways. It's my wish. But which one is correct? Because what is the definition tell? To the value x, you need to add something. In the first one, what has happened is pi I have added, but I have not added to plus 6, I have added to minus 6. So x should not become minus. Because the function that I took is sin x only. If the argument is x, here also I should have x only. So the second one is right and the first one is wrong. So sin x is said to be a periodic function of what period? Of a period 2 pi. Meaning of it, for every 360-degree revolution, sin of 2 pi plus x will be sin x. So that is a period of time. That is why when you observe the graph of sin x, right? You might think this graph is not needed. I repeat it again, this chapter demands a lot of mathematics. I will be touching them. Any doubt you have, asked. So if you look at the graph of sin x, it goes like this. So this is sin x. This is x. It keeps going in this way. So this is called as the positive cycle, negative cycle, positive cycle, negative cycle. You know what the angles are? 0, pi by 2, pi, 3 pi by 2, and this is going to be 2 pi. If you observe the graph, after a completion of 2 pi radian, see if you cut it and keep it here, it will exactly overlap. That is why after 2 pi radian, the graph is continuously repeating itself. That is why the period of sin x is. In a similar way, if I give you the function f of x is equal to cos x, what will you say? So you need to start thinking. You can either add a pi or a 2 pi. So cos of x plus pi. Cos of x plus pi means that you are entering into third quadrant. Third quadrant, the cos is positive or negative? It is minus cos x. So it's not f of x, it's minus f of x. Up a cos of x plus 2 pi. See, if you're not able to do it in mind, the cos of x plus pi is minus cos x. Whereas cos of x plus 2 pi is cos x, because you're entering back into the first quadrant. So what is the period of cos x? 2 pi. That is why if you see the graph, it keeps repeating itself. You're able to understand? So this value is what is 2 pi. So if I take the graph, cut it and paste it on top of this, it will exactly overlap. Similarly, what is the periodic? Is tan x a periodic function? Of period what? You need not think in terms of graph. First, think in terms of adding the angle. Tan of x plus pi is equal to tan x, because x plus pi means you are entering into third quadrant. Third quadrant tan is. So it is having a period of pi. Here. Similarly, you can check for the other functions also. In that part, I'm giving it to you. So since we discussed about periodic function in this chapter, the two important Trigonometric functions that we need are sine and cos. Tan is not needed. Because except sine and cos, every other function is discontinuous. What is the meaning of it? At some point, there will be a break. It is not defined. So where is tan not defined? Can you give me a general solution? 2n plus 1. Odd multiples of pi. It's not only 90. Pi by 2, 3 pi by 2, 5 pi by 2, minus pi by 2, minus 3 pi by 2. Odd multiples of pi by 2, not different. Similarly, what about cosecant? All integral multiples of pi. Similarly, cosecant, secant. Simple, secant is not defined wherever cos gives you a 0. Where does cos give you a 0? Odd multiples of pi by 2. So wherever cos is giving you a 0, secant will give you infinity. Infinity not defined. That's what domain says. Can someone define what is domain? Hariharan? In your own words, I don't want any good definition. What is the domain of a function? What is your understanding of it? Meaning function is defined in a defined another. Sin x na get na I'll say it is defined only, no, why you are saying this. We'll get a finite value basically. You should not get infinity. So if you're given an option to plug in different values of x, you can substitute all values of x from the real number system, except those values for which tan is giving you infinity, other than domain. So similarly, where will cot be discontinuous? Where is cot discontinuous? This is another limits and derivatives here. Wherever sine is giving you a 0, there it is. Cot is going to give you infinity. Tan for the pi by 2. Cot. Cos by sine then. Cot is cos by sine. No? So wherever sine is giving you a 0, cot will give you 0. Cot will not be different. So I remember it like that. Now I break down everything only into terms of sine and cos. Tani function. Okay. So now you would have understood why we are using only sine and cos, because sine and cos has a domain of real number. So throughout the real number system, what is happening? Sine and cos both are continuous, means the limit is defined at every point. Secondly, what is the range of cos and sine? Range now y values. Graph or a refer. What is the least value you are able to see? What is the highest value you are able to see? -1 to 1. So have all these points in mind. Okay. Now I'm going to define another term which is called as harmonic motion, or I'll call it as oscillatory motion in the first place. So I'll call it as oscillatory motion or vibratory motion. Both are same. So what is an oscillatory motion? What is the difference between periodic and oscillatory motion? What is the fixed point called as? Basically, oscillatory means, as the name suggests, something is oscillating. So which has a to and a fro motion about the fixed point called as the mean position. So suppose I assume there is a string tied to an object and it is pulled in this way. Okay, I'm pulling it, taking it to the extreme point and releasing it. What will happen? What are the energy conversions taking place in the first place? Here it is having potential energy. Potential energy gets converted to kinetic energy, right? And from here, the kinetic energy again gets converted to potential energy. It won't stop at a particular point, right? Again, it stop, again come back. So is it not called as a to and fro motion? So this to and fro motion acting about a fixed point called as the mean position is what we call it as an oscillatory motion. See, oscillatory motion, we need not think of only this condition. It can happen linearly also. It's called as a linear oscillator. If I have a mean position, I can think of a particle vibrating like this. Are you able to understand? For example, your sewing machine is there, no? Then what happens to the needle? It goes down and comes up. So that is actually a linear vibration. Whereas if you take a string and tie it to a ball and leave it, it is going to take in this way. In a curvature, it is going to follow an arc path. Right? So this is where the question comes. So when I talk about the to and fro motion acting about the mean position, you call it as an oscillatory or a vibratory motion. Okay. Now my question is very simple. Every periodic motion is oscillating. Is it right? Every periodic motion is oscillating. No. But what about every oscillating motion is periodic? Yes. Okay. So every periodic is oscillatory. It's a wrong statement. Every periodic motion is not oscillating. Example. For example, you think of a clock which is revolving, the ants of a clock which are revolving. It is not an oscillatory motion. It is just a periodic motion. Right. So what is necessary for you to call that kind of a motion as an oscillatory? You need a to and a fro motion, and you definitely need a point called as a mean position. If that is not there, don't define it at all. Okay. So sometimes this kind of a motion is also called as harmonic motion. Okay, it's called as harmonic motion. Is that clear? Now the next question is fourth one. I'm going to define something called as harmonic function. Function comes, I told you it is mathematics. So basically, what is a harmonic function? If you are able to write any function in terms of only sine or only cos. I repeat it again. If I give you a function and that function is able to be written as a single function of either sine or cos. I'm not saying sine and cos. No. If there is an expression in terms of sine, it should only be sine. If there is an expression in terms of cos, it should only be cos. Means you can either write a function in terms of either sine or cos completely. That kind of a function is called as harmonic function. Okay. For example, f of x is equal to sine x. This is a harmonic function. Obviously, yes. F of x is equal to cos x. This is a harmonic function. Yes. F of x is equal to 3 sin x. Is it a harmonic function? Yes. F of x is equal to 5 cos x. Yes or no? Yes, it is. F of x is equal to sin 3x. Yes. F of x is equal to cos 3x. Yes. F of x is equal to sin x into cos x. So all these are S. F of x is equal to sin x into cos x. Is it a harmonic function or not? It is not. Correct? But that is wrong. It is a harmonic function. What did I tell you? You should be able to write it as a single function of sine and cos. Whenever sine and cos of the same argument are multiplied, you can always multiply and divide it with 2. So it is actually half of sine 2x. It is half of sine 2x. So you should always look at the function. See, generally, this level of toughness is not there in CBSE, but you need to have clarity to understand. Learn a chapter per year. Okay, they'll not involve so much of mathematics, but you can do. So this is half of sine 2x. Now, if I put the question like this, f of x is equal to sin x cos 2x. This is a harmonic function. The answer is how? See, you have to use your trigonometry knowledge, nothing else. Whenever you have sin A cos B, what will you do? You'll multiply and divide the two in the first place. So I'm repeating this, very important. Next year also you have it. You will multiply and divide it with 2. So what will happen? Half of 2 sin A cos B. Actually, now I look at the bigger argument. 2 cos A sin B is basically what? Sin of A plus B, that is sin 3x minus sin of A minus B, that is x. So if you solve this, you will get this. Okay, you would have solved these kind of problems, I believe, in miscellaneous, right? In trigonometry. So you solve this, you are going to get this, but this is not a harmonic function because it is not expressed as a single function of sin. Sin plus sin is not harmonic. So you should be able to express it as a single function of sine or cos. Did you guys understand the examples? Right. So don't worry. Not from exam point of view, it is only for knowledge purpose. Okay. Now, I'm going to give you some more definitions with respect to a oscillatory motion. So with respect to an oscillatory motion, there are some more terms that you need to understand. First is something called as an amplitude. So what is amplitude? Name is suggesting amplitude means maximum displacement. So maximum displacement of a particle from its mean position is called amplitude. So maximum displacement of the particle from its mean position is called as amplitude. So if I take this to be the mean position, let's say the particle is vibrating in a linear path. If I take this to be A and this to be B, okay, then if I take this okay, I'll call it as PQ. If I take this to be P and this to be Q, this amplitude, if I take it as A, this will be minus K. Because what is the word I used? I didn't say maximum distance. I told maximum displacement. Displacement can be positive or negative. Okay. So obviously, what is going to be the SI unit of it? It's going to be meter, and the CGS unit will be centimeter, right? So this is something which you would have understood. Next is something called as time period. So time period is represented by the symbol capital T. Okay. So what is time period? As the name suggests, it is the time taken by the particle to complete one full oscillation. Right? Time taken by the particle to complete. See, we generally call it as one oscillation only. One oscillation means full only, but I just wanted to stress on that term. So it's called as time taken by the particle to complete one oscillation. Right? So observe this. The particle is here. Initially, if it is at mean position, right? So I have displaced it to this point, right? So this is the maximum displacement from the mean position. I'll call it as amplitude. So how much time does it take for the particle to go? So if I start the motion from here, I'm not starting from mean position because it starts to oscillate after I release it from here. how much time does it take for the particle to go from the extreme position to the mean position? It takes t by 4 units, where t is the time period, by 4. So it takes 1/4 of the time period to go from an extreme point to a mean position. Why is it so? Because if you try to break this journey into multiple parts, from extreme point to mean point, 1/4 of the oscillation is over. From here to here, half oscillation is over. From here to this point again, 3/4 of the oscillation is over. And from here to here, 4/4 of the oscillation, that is one complete oscillation. So 1/4, 2/4, 3/4, 4/4. 4/4 is 1, 4 by 4. Right? So that is why the time taken by the particle to always go from the mean position to the extreme point or the extreme position to the mean point is exactly 1/4 of the time period. This is an important point we need to understand to solve problems. We will see the reason also, mathematical reason also, after I show you the derivations. So as of now, I hope it is clear, right? So it takes 1/4 of the time period to move from mean position to the extreme point. Clear? So the next term is called as frequency, which is represented by the symbol F. So what is frequency? Don't say reciprocal of time period. It is the number of oscillations per unit time. What is it? Number of oscillations per unit time is what is called as frequency. And how is frequency represented as? It is written as 1 divided by t. Number of oscillations per one time period. Why I wrote 1 by t is because one complete oscillation is completed in how much time? One time period. So number of oscillations, one oscillation takes one time period. That is why it is 1 by t. Okay. The next term that we are going to see is called as angular frequency, which is represented by omega. So what is angular frequency? The number of radians per unit time. So what is the number of radians per unit time? So if I take omega, in one time period, how many radians is covered? If I take a circular motion, for instance, you can think of something like this. When you're talking about oscillatory motion, why are we talking about angular frequency? See, if I have a linear oscillatory motion, why would the particle have angular frequency associated? There is no angle itself. Why are we speaking? You will understand it. Why is it so? But as of, if I put a question, number of radians per unit time means, if a particle is revolving in a circular path, for instance, because oscillatory motions are periodic in nature, I can take a periodic motion to understand what is angular frequency. So when I take a periodic motion as a circular motion, to complete one full revolution, how much time does it take? One time period. In that one time period, how many radians is it covering? So omega is equal to 2 pi by t. This we have solved it many times. So 2 pi, 1 to 1 by t is there, no? Can I write that 1 by t as f? So now we are able to understand why omega is 2 pi f. So how is omega measured in? So frequency is measured in second inverse or cycles per second, or you write it as hertz. H-E-R-T-Z. Am I right? What about omega? It is measured as radian per second. Right? It is measured in radian per second. That is angular frequency, number of radians per unit time. Is that clear? I'll show you something. Just give me a minute. So listen to this. I wish I could do this practically, but not possible. See, listen.
A very interesting point about a simple
So
harmonic
there
motion
is,
is
you're able
that
to see a particle oscillate.
it-
You're able to see a particle oscillating.
can be considered as a projection of a uniform circular
But
motion.
actually, what is happening? So this particle is actually in a uniform circular motion.
That is,
So when you see a particle
a uniform
this,
circular
in
motion,
the uniform circular
when
motion,
viewed
you see the
sideways,
same thing from different perspective, it will appear like a harmonic motion. So observe what is happening.
is a simple harmonic motion.
It's actually moving in a circular path, but how is it appearing to us? Because you're seeing from the side. So
We
it's
can also
appearing
consider
like
a simple
as
harmonic
this
motion
oscillating with a fixed
to be a
position.
shadow
Now,
of a
what we
uniform
can do
circular
is,
motion.
if I take the same condition, okay, if I take the circular motion like this and I make the room completely dark, I keep a wall here so that when this particle is revolving in the circular motion, this particle's shadow is captured on the screen. So the screen, where is it? It is exactly in the direction in which your eye was there when you saw it like a straight line motion, like an oscillating motion. Whereas it was in a circular motion, right? So if I keep it like this, if I place a wall here, right, I'll be able to see the projection as a circular motion because its projection will fall there. Whereas if I place it here and if I place the wall here, then here I'll be able to see something like this. Observe.
We can also consider a simple harmonic motion to be a shadow of a uniform circular motion.
So what is happening actually? So if wherever I stop, right, see, observe, if there was a string, elastic string attached between both, how is it appearing?
Let us say
The particle is in
that
circular
the angular
motion.
speed of a particle
These two objects
moving
are
along a
connected.
circular
How
path
is it appearing?
of radius a
This uniform
is equal
circular
to
motion,
omega.
when projected
If the
on
particle
the
starts from
screen,
this
what
position,
is it? It's actually not
then after
the same motion that is happening. Both the motions are different, no doubt in that. But if I take the motion of an object which is in the uniform circular motion, and from every point, if I keep dropping perpendiculars, which is technically called as projection, when I drop perpendiculars, then one thing I'll be able to observe is when this particle is somewhere on the circumference of the circle, if I take this mean point, this is the mean point, right? If I take this point to be the mean point, then with respect to the mean point, I'm able to say that the particle has got displaced. What is the particle? Actually, it is a shadow. The shadow has got vertically displaced from the mean position of whom? Of a uniform circular motions projection. Are you able to understand what I'm trying to say? So, if I draw a line like this, and I call this as a mean position, had the particle been here, then what would be this position? Had the particle been here, this would have been a mean position. As the particle moved here, if I drop a perpendicular from the mean position, I am able to see some displacement. Correct? If it goes to this extreme point, and from here, if I drop a perpendicular, then this is going to be the amplitude. Correct? With an amplitude. What is amplitude? Amplitude is the maximum displacement. Is there a possibility where in the projection is there a possibility where you can take the amplitude beyond that? You will not get the projection because the particle is confined to this rim. Similarly, when it goes to this position, what will happen? So when it is going in the anti-clockwise direction, when it goes from 0 to 90 degrees, I am able to see that the particle is ascending. Again, from 90 to 180 degree, I am able to see that the particle is traveling towards the mean position. From 180 to 270, I am able to see that it is ascending in the downward direction. And from 270 to 360, it is again coming back to the mean position. So what I am trying to say here is, whenever you take, see, I'm stressing on this point, it is not circular motion, it is uniform circular motion. Whenever you take a uniform circular motion and project it on a screen, right, it appears like a simple harmonic motion or an oscillatory motion. The same logic, imagine, instead of me keeping a wall, I had kept a ceiling, then what would happen? If I shadow capture, what would happen? Even the projection would happen. So when the particle comes here, it gives nothing. So I should take this as a mean position. From the mean position, you can see that the particle is oscillating like this. Whereas when on the vertical, it is oscillating in this way. So you can either keep a wall or a floor or a ceiling. Anywhere you can capture it. Are you able to understand? Visualize it. Ceiling level, this will be the mean position. So when the particle is here, okay, near the mean position. When it goes in this way, get the direction to where it is. If the water stays in this direction, you can get over the water stays in this direction. So it keeps oscillating in the horizontal vibrating motion. Here it is in the vertical vibrating motion. So if I take, I just need the screen alone. So if I look at this particle, now see what I'm going to do is, from here, I'll drop a perpendicular. I'll drop a perpendicular. This is going to be the mean position. So can I call this displacement as y? Okay. Now, who is deciding the amplitude of this particle? Who is deciding the maximum displacement it can take from the mean position for the blue color particle? It is the radius of the circle. Correct? You know, it can go only to the point. This is tangential to this. It cannot go here. It cannot go. So, if I take the radius of the circle to be capital A, right, and if I take this angle to be theta, means the angular displacement taken by the particle to be theta. Angular displacement of which particle? Of the particle in uniform circular motion to be theta. Then what is the value of theta? Theta, can I write it as omega into t? Because alpha is 0 because it's a uniform circular motion. Right? So, if I take this distance to be y and this distance to be x, what is y divided by a equal to from basic trigonometry? Y divided by a is sine theta, which implies y is equal to a sine theta, or I can write y is equal to a sine omega t. And this is the reason, or this is the equation for a particle. Equation for particle in SH. The equation, you have seen this? Y is equal to a sin omega t, or x is equal to a cos omega t. The reason for that is, so the first question that's strike your mind is, whenever you're saying a particle is in a linear motion, why is omega coming into picture? The omega is actually coming into picture because we are drawing the analogy from a uniform circular motion. Right? So this topic is called as projection of a uniform circular motion onto a section. Right. Projection of a uniform circular motion onto SHM. Right. This is the equation for a particle essentially. Similarly, if you want to write in terms of x also, you can do it. What will x by a be equal to? It will be cos theta. So x is equal to a cos omega t. Right? So this is also an equation of simple harmonic motion. So that is why I told you, whenever you have a particle in a harmonic motion, you should either be able to write it in terms of completely sine or completely cos. Right? And these kind of functions are called as sinusoidal functions. Why we call it as sinusoidal? Because sine and cosine both are sine functions. What does cos stand for? Complementary of sine. Are you able to understand this? It's a simple point. Because that is the maximum displacement of this particle. If the particle comes here, when you drop a projection, then this is going to be the amplitude. Beyond that, the particle cannot go no. Is there a possibility where you can push this particle beyond this? Because the projection itself is taken from the motion of the circular motion. That is why that decides, the radius of the circle decides the amplitude. Is that clear? So, there are two small points that I want to derive and show you. So, what did we say? Y is equal to A sine omega t. Correct? Let this be equation number 1. Now, if I differentiate this with respect to time, if I write dy divided by dt, then what will I get? I will get A into, what is the derivative of sine omega t? It is cos. Integral is minus cos. cos omega t into derivative of omega t, because I need to follow something called as a chain rule, which I've explained in differentiation, if you remember. Chain rule, what will you do? Into derivative of omega t is omega. So it will be a omega into cos omega t. So this a omega into cos omega t is actually going to be the velocity of the particle at any instant t. Okay. So listen to this carefully. If I have y is equal to a sine omega t, then what is sine omega t from this? It is y by a. Then what is cos omega t? Cos omega t is root of 1 minus y square by a square, that is a square minus y square divided by a square. So can I write it as root of a square minus y square by a? Yeah, because cos theta is root of 1 minus sine square theta. So 1 minus sine square theta and y square by a square, take LCM a square minus y square by a square. Put it here. So Vp is equal to the velocity of the particle is this thing. So can I write this as a omega into, in the place of cos omega t, can I write it as root of a square minus y square divided by a? A and a will get cancelled. So omega into root of a square minus y square will also be the velocity of the particle. Means what I'm trying to tell here is, when you're writing the mathematical equation for displacement, velocity, and displacement, obviously it is written in terms of time. Whereas when you write the expression for velocity, velocity can be represented in terms of time as well as in terms of displacement. In this equation, observe there is no displacement. Sorry, time. So it can be written in terms of displacement also. Now, if I take this Vp and differentiate it with respect to time, then what will I get? I will get a omega is a constant. Why is a omega constant? A is the radius of the circle, omega is the angular frequency. For a uniform circular motion, angular frequency is a constant. A omega into, what is the derivative of cos omega t? It is minus sine omega t into derivative of omega t is omega. So what will be the answer? Minus a omega square sine omega t. Can I write it like this? What is a sine omega t? That is y. Because y is a sine omega t, correct? So it is negative of omega square into y. Then what is the derivative of velocity with respect to time called as? It is called as acceleration. And AP is equal to minus omega square y. This is a very, very important expression because this is the mathematical condition for particle in SHM. So what should happen? Acceleration of the particle should be negative of omega square y, meaning acceleration of the particle is always in direction opposite to displacement. So acceleration of the particle is always in the direction opposite to displacement. Why did I conclude opposite? Because omega square is always positive. So if you put a to be negative, y will be positive. If you put a positive, y will be negative. So it keeps changing. So whatever sign you give to y will always be opposite to a. So if someone asks you a question, what is the necessary condition for you to conclude that the particle is always in SHM? What will you say? Acceleration of the particle should always be in the direction opposite to the displacement because of this mathematical condition of minus omega square y. Based on this only, we will be deriving the time periods of different kinds of motion. Okay, so have this in your mind. Make a note of it. I hope you could understand. These are all very important expressions. I want you to practice this and come. Maximum 2 more classes. The chapter is small. Maximum 2 more classes will be done, and then we can go to rings. So I repeat, those who have not completed thermodynamics, they are not uploading the notes by tomorrow, don't come. Sine or cos? Sine and cos both are sinusoidal. Harmonic functions, you generally call them as sinusoidal equations because you're writing in terms of sine or cos. Clear? So the reason I'm saying I have to stop with this because it will become too much if I go beyond. There are a lot of mathematics involved. I'll be preparing a tabular column based on these particular expressions. You will understand. I showed you the t by 4 and everything. You will understand why the t by 4 is actually coming. So you have to practice them and come by tomorrow. So take 15 minutes of time. You revise all these concepts. That's enough. It's easy to practice. Okay. Revise and come for tomorrow's class. Okay, those who are online, any doubt?
Sir, I have a doubt.
Yeah, tell me.
Sir, how is theta equal to omega t, sir?
S is equal to ut plus half at square. So theta is equal to omega naught into t plus half alpha t square. For uniform circular motion, alpha is 0. So theta is equal to omega t.
Okay, sir.
Okay. Any other doubt? That's it. Then we'll wind up. Those who are online can read.